this video, I'll introduce you to using Stata. I'm going to open up a data set from the American Community Survey using observations from North Carolina. So you can go to your downloads folder if that's where you've downloaded some data and just open the file, the .dta file. I think that'll automatically open in Stata. I just navigated to it in my downloads folder here. I'm going to open that. You can see it's called ACS NC 2022. So these are observations from North Carolina for calendar year 2022 in this survey. And I've limited it to people who are what are called prime working age, which is ages 25 to 54. So we've got the data open now, and one thing that I'll point out right away is that unlike in R, Stata sort of was created with a default of operating with one data set at a time. And so the scripting in Stata, the commands in Stata, are generally simpler than the equivalent thing in R, and that's because there's an assumption about what data is being operated on, whereas in R you need to sort of specify what object you're working with. It's also limiting in Stata, although they've built in now ways to sort of be flexible with that and have multiple data sets loaded. So one thing you'll notice is in the it may look different depending on how you have it set up or what the defaults are on your system, but in mine, in the top right here, I see a list of variable names and labels. So that shows me the different variables. You can also, sometimes these variable names or labels might be quite long, and it might be more helpful to, you can see in the lower left here in the command window, just hit describe or type describe, hit return. And if you do that, it will give you some information about the data set, including the number of observations, 36,000-ish, number of variables, and it'll print like the longer versions of the variable labels and names and so forth. You can also see there's a properties panel down here, which will tell you some basics about your data: name, variables, observations, size of the data set, and so forth. Okay, let's just look at our data before we do anything with it. So if you look on the top bar here, there's a label here that says Data Editor, and there's two buttons. The one with the little pencil icon will allow you to actually edit the data manually. Generally, you don't want to do that. So I'm going to go for the one with the little magnifying glass icon. This is called the browser or data browser in Stata. And it's just going to pop open a basically a spreadsheet view here. So every row is an observation. In this survey, that is one person. And the columns are different variables. According to this is that same list of names and labels. You'll notice immediately that some things are printed in black and some are in blue, all right? And we'll see why in a moment. Variables that are purely numeric are printed in black. So one of the variables that we will work with in just a moment is weeks worked, all right? So this is over the previous 12 months, how many weeks the person worked. There are 52 weeks in a year, so you see a lot of 52s. You see some people who may not have worked, and you see some other observations, 47, 48, and so forth. Okay. You'll also see like total personal income here is a numeric variable. Family total income right here is a numeric variable, and so forth. So those are in black, just purely numeric variables. The ones that are in blue are numeric variables that have what Stata calls value labels attached. And so one of those that we'll work with is employment status, right? So let you see a little bit more of that, employment status. And you'll see some are employed, some are something else, right? You can, just like, in Excel or something like that, you can stretch the width of those columns, and you'll see that not in labor force is an option, and there we go, we have someone who's unemployed, which means not working but actively searching for work. Notice, you see right here, it prints the numeric code underneath this. So this is a categorical variable that's stored as a numeric. but there are these text value labels attached. So if you click on an employed cell, you can see employed is 1, unemployed we just saw is 2, and not in labor force is 3. Right? So that's a categorical variable that's being stored as a numeric, but with value labels to make it sort of more readable what's going on here. Another example of that is sex. You can see male is coded as 1, female here is coded as 2. Right? So those are numeric variables with value labels. And then finally, we don't have any in this data set, but a string variable, so just like text, so it's not being stored as a number, it's a string, those would be printed in red, so it'd be clear which ones those are. All right, let's use Stata to get some summary statistics, okay? And let's start actually with that categorical variable, which was employment status. So I'm going to use the tabulate command, which I can shorten to just tab, to get a table of different values of employment status and how common they are. And when I do that, you can see Stata generates this nice compact table here to say how many observations belong to each of these categories and what percentage of this sample do they represent. If I wanted to get a sense of the distribution of a continuous variable, like you can see here the next to last variable, wage and salary income. Well, I don't want a table of all the different values it can take on. What I want is the summarize function. And Stata will show me number of observations, mean, standard deviation, min, and max. Now say I want more than that. Maybe I want to know the median. How do I find that? In Stata, let's imagine we didn't know how to do this. You can get help on a command like this. So just help summarize. And it brings up a help file here, and it shows that there are some options. And we're going to use the detail option to display additional statistics. Stata is pretty good at having examples of all these commands to show you how it might be used in different ways. You can, for example, list multiple variables, and it will, give you line by line sort of summary statistics for each variable, which is helpful. We're going to use that detail option. I want to show one other thing, which is you'll notice a lot of this stuff is like some of the letters are underlined at the beginning. That is sort of a minimum abbreviation that you can give. So I could shorten summarize to just SU, although personally I like to see the M as well, so SUM just tells me summarize. And notice it gives you the syntax here in sort of general form, and the options, if you put one or more options, needs to be after a comma. So let me abbreviate summarize to just SUM, and I'll ask for that same variable, wage and salary income, and I'll get the detailed option. All right, so now we get everything we got before, plus some common percentiles that might be of interest, including the median here. Now you'll notice very quickly here, first of all, at least 10% of the sample has 0 wage and salary income. These are people who didn't work over the previous 12 months, all right? And then you'll also notice it prints the smallest and largest 4 values, and the largest 4 values are all exactly the same. That seems unlikely, and indeed it's this is not the actual income values for these people. You're seeing an example of what's called a top code. So for people with very high incomes, it may be that if you knew demographic characteristics of that person and you knew their exact income, you might be able to identify who that person is because, for example, publicly traded companies have to report the income information for certain executives, and so you might be able to figure out who that record is in the data. So for privacy reasons, some variables like this are what's called top-coded, and you're seeing an example of that. So this number really just means at least that high and possibly higher. Now say we wanted to get summary statistics on earnings, wage and salary income, but we only wanted to do it for people who were working. What I can do there is use an if statement. Specifically, I want to summarize this variable, but only for positive observations of this variable. And so Stata is going to go through and it'll evaluate row by row if this condition is met, and it will only do the summary statistics for cases when this is true. And let me also get the detail on this. All right, there we go. So we see some people with very small incomes, but for the most part, we see a very reasonable looking sort of distribution here. You can see the mean is considerably higher than the median, reflecting a strong right skew and so forth. Okay. Now let's say we want to generate a new variable. Maybe I want to look at weekly earnings. So I'm going to generate a new variable that I'm going to call earn week. So this is weekly wage and salary earnings. And we'll form it as the yearly earnings, which is the variable we've been working with, divided by the number of weeks worked in the last year. That's the one I showed you in the data browser before. I can drop in the name of this variable. I could certainly type it in the command line, or I can just click on the little arrow here and it will drop it into the command line wherever the cursor is. And so I've created that, and Stata says it generated a little over 5,000 missing values. So what happened there? Well, we have people who didn't work, and so the denominator is 0, and those folks, we're not going to be able to compute weekly wages for them. So if I go to my data browser, you will see, first of all, in the variable list, that new variable is at the end. In the data browser, here it is in the last column. People who had 0 weeks worked, like rows 10, 14, 19, those have missing values here, and in Stata those are just represented by a period. Everyone else, who did work has a positive, valid observation for weekly earnings. All right, let's do a little bit more on this. Let's say we want to look at the distribution of weekly earnings separately for men and women. So remember, we saw that male is coded as 1, female is coded as 2. And let's look at distribution of weekly earnings for men who have positive earnings. All right, so the and statement here is going to evaluate this, and it's only going to give me statistics for the subsample for which both of those things are true. And I'm going to add, we're going to go even a little bit further than that, which is a lot of these household surveys, end up, well, sometimes they intentionally over or undersample certain populations. So it's common in US data, for example. Surveys may intentionally oversample race and ethnic minority groups, or sometimes people that live in small population areas or states. And this is so that we can have enough observations on those groups to, make maybe valid inferences about them. And so the surveys then come with a variable, which you can see right here, person weight, PERWT. In the data browser, it's right here. All right. So this is essentially the inverse of each person's probability of having been sampled from the population, all right, which explains what those numbers are. The ACS tries to get a 1% sample of the US population every year, so you can think of the default value here as being 100. Higher values give that person more weight, and lower values give the person less weight in the resulting statistics. So this is being used as a device to get back from our sort of weighted sampling design back to sort of nationally representative statistics. Right? And usually in Stata, you want what are called analytic weights, hence the AW. And you do AW equals, and then you specify the variable that contains the weights in the data set, and you put that all in brackets. And this can go either here in your command, or it can actually go like before the if statement. Stata doesn't care which one. I usually put the if statement first, but that's just a personal habit. Any options go after that. So this weight statement does need to appear before the comma and any options. All right, so this is the weekly earnings distribution for men. You have a certain number of observations. You can see mean, median, and so forth. Let's do the same for women. So I'm going to make my life easier by just copying and pasting that and just changing the 1 to a 2. And that gives me the weekly earnings distribution for women. You can see their average earnings are about a little over 80% of the value of average earnings for men. Let's look at one more thing here, which is a correlation coefficient. So say I wanted to find the correlation between earnings and education. And let's go ahead and do person weights for that. And Stata will give you a little matrix where you can see the same two variables here in the column headers, row headers. Correlation coefficient is this value right here, the 0.24. So clearly these variables are positively correlated, although maybe less so than some people would have guessed initially. So that's some basics of working with if statements, weights, generating new variables, and summary statistics in Stata. Let me show you one more thing, which is that it can be very helpful to create a script file of your commands to sort of try out and then edit and try again as you're trying to figure out what exactly you want to do in Stata, and to preserve your work in case you need to go back to it later. So this is Stata's equivalent of if you've done a script file in R Studio. In Stata, these are called do files. So you can see right here it says do file editor. I'm going to click on the button here. You can see with the pencil icon, new do file editor. And I'm just going to pop in, let's see. So I have that, and obviously I don't have the entire sort of history here of things we did. I can put a couple things in. It has autocomplete on some stuff that can make your life a little bit easier maybe. Okay, that's enough to show you the idea here. So this script is just a list of commands. If you want to pass these to the command line in Stata, then you could like select a row and just click the sort of play icon here, and it will pass just that command. All right, let me do one more thing, which is probably be good practice to save our do file. All right, so we can go back to it, and again, I can choose any of these commands and just pass that one part to Stata, and it'll just do that. Or I could, if nothing's selected, I could press this, and it will run, I think, the entire thing. All right, so you can see here when I press that, it ran the whole do file, and that included all 3 commands here. Right. So maybe you don't need a do file for 3 commands, but for some of the stuff that you do, you might have a longer list of things. It can be very helpful as you're sort of debugging or trying to figure out what commands you want to run to attempt something in here, try to run it, and if it doesn't work, just make some edits and try again. All right, so that should help you get started, hopefully, in using Stata.